All right, welcome to Applications of Calculus 2. So today we're going to talk a little bit about derivatives, just to give us a refresher about that. Remember, derivatives were, we use those for calculating rates of change. So like that's a big important thing about those. We're going to be we're going to be doing mostly integrals, but in the process of taking integrals, we're going to have to take derivatives to deal with some things. So that's what the class is going to have. So the first week is just a lot of review. I don't know how long it's been since you've had Calculus 1, but we have to go back over all of the skills that you learned for that and make sure that you're up to par with everything that we did in Calculus 1. Okay. Mostly this is just taking derivatives and doing a lot of review about what happened. So if you remember that the derivative, the definition was the limit, okay, as h approaches 0 of f of x plus h minus f of x all over h. Okay, and then we went through into that. Now, this is the definition of the derivative. If you remember things about derivatives, um, for you to take a derivative of a function, it had to be smooth and it had to be continuous. So if you end up having like some kind of a function that looks something like this, right? Whether we have a jump there, you can't take the derivative at that point. The reason why we teach you the definition is because in real life, like you guys do laboratory scientists for the most part, you're going to get like a scatter plot, right? You're just going to have like some dots, and you'll go ahead and maybe you'll connect the dots, maybe you won't. Okay, some places do, some places don't, depending on the application of what you're graphing. But at that point, it's like, well, how do you take the derivative of like this corner here? Like you can't, because anytime you've got like some kind of a corner, right? If you take the derivative on one side, you get one answer. You take the derivative on the other side, you get a different answer. Okay. And that's an issue. So the reason why we keep going back to the definition is because in school, you pretty much get polynomials, exponentials, and logarithms to take derivatives of. As soon as you get out of school, they want to know what's the rate of change of what's going on here. And you're going to have to numerically figure that out. And this is what we go back to in order to do that. So you'll get a spreadsheet to find the derivatives. Okay. So that's a big thing for that. Now, going back to some rules about derivatives, we have the power rule. Okay. So we have, if I want to take the derivative of an x to the n, right? The x, that's just going to be the exponent comes down in front. So we have n x to the n minus 1, and that's our derivative. Okay. We also have derivatives of exponentials. So we have d by dx of e to the x, and this is just e to the x. Okay. Now, there might be a chain rule that goes on with this. Okay, we'll do that in another example in just a second, but that's the basic rule. Again, for logarithms, you take a derivative of the natural log of x. Okay, what this is going to do is this is just going to be 1 over whatever the argument is times the chain rule of that argument. Okay, so that's just going back over the basic rules that you've been taught in Calculus 1. And the first homework assignment asks you to do this a lot for a lot of different problems. So just to go through and maybe look at an example or three, we can go ahead and start looking at that. So what if we wanted to take the derivative, let's say, okay, 5x to the fourth, just taking this derivative with respect to x, we're going to say this is 5 times 4x to the 4 minus 1. It's okay if you leave it like, we'll simplify it, but if you need to write this thing in just to remind yourself that this is how this works, that's okay. 5 times 4 is 20, so we get 20x to the third. Okay. Similarly, if we want d by dx of a line, mx plus b, right? We go ahead and take the derivative. It distributes over a plus or a minus sign. It will not distribute over a times. That's a different kind of formula. But we're going to take the derivative of mx. So this is mx to the 1. The 1 comes down in front. So we have 1 times mx to the 1 minus 1. Even though 0 to the 0 is an indeterminate form, we're going to say so x to the 0 is going to be 1. So we're going to say that's just going to be our m. Just get the slope when you take the derivative. So, and the derivative of a constant, of course, is 0. So if I want to take the derivative of a line, our answer is just going to be whatever the slope was. Okay. So let's look at a couple of examples here just to kind of see like some problems. So let's see. We could do d by dx. Let's go ahead and let's do a 4x to the 3. Let's do okay, we're just doing formulas with this one. 3x squared plus 7. We go ahead and take this derivative. Again, we float through the plus signs here. So what we're going to have is we're going to have 3 times 4, which is going to be 12. X to the 3 minus 1 is 2. Okay, so go moving on to the next part. We have 2 times 3 is 6. So we have plus 6x. X to the 2, 2 minus 1 is 1. You don't have to write the 1. It's always assumed that it's there. And again, the derivative of 7, it's a constant. So that's just going to be 0 for that part. So that's our answer for the derivative of 4x cubed plus 3x squared. Okay, so let's go ahead and see. What if we wanted to take the derivative of e to the 3x? Okay, that's going to be e to the 3x because the derivative of the x function is e to the x function. So e to the u is e to the u times the chain. So I need what's the derivative of the thing inside of it? That's my derivative of 3x. And we're going to say, okay, this is going to be 3 times e to the 3x. And that's my derivative for e to the 3x. All right. Let's try one that's a little bit harder. What if I want to take the derivative of, let's look at natural log of 1 plus the square root of x. All right, that's one's a little bit tougher. A couple of things I'm going to do first is I'm going to break the square root into x to the 1/2 power. So we want d by dx of the natural log. I haven't taken the derivative yet. 1 plus x to the 1/2. Okay, we'll see what that's going to do for us. So the derivative of the natural log function just says put whatever's inside the argument here, put it in the denominator of my fraction here. So it's going to be 1 over 1 plus x to the 1/2 power. Okay, that's just the derivative of the natural log part. But just like in the last problem, we have a chain rule going on, so I need to take the derivative of the inside here. So I need the derivative of 1 plus x to the 1/2 still. Okay, we're not done yet. So this is going to be 1 over 1 plus x to the 1/2, and now I need to take the derivative of the inside function. The derivative of 1 is just going to be 0, and now I need the derivative of x to the 1/2. That's going to be 1/2 x, and then we have to say 1/2 minus 1 is a negative 1/2 here. Okay, so in total, this thing is going to be, 1/2. I have 1 over 1 plus x to the 1/2. Because I have a negative exponent, I'm going to just put it on the bottom of our fraction. So that's x to the 1/2 here. And then we can go ahead, because I don't have the 1/2 on the outside, so just on this one term, we can go ahead and factor this in. This is going to be 1 over 2. And I have 1 over x to the 1/2. And then for this other term, when the bases are the same, we add the exponent. So we have x to the 1/2 times x to the 1/2. The bases are the same. We add the exponent. 1/2 plus 1/2 is 1. So we're just going to have x to the 1 power here. So that would be my derivative of natural log of 1 plus the square root of x. All right. So we have plenty of problems like this. I'm going to say this in passing for you in conclusion. Please try to do the homework honestly. I will never know if you look it all up on Reddit or if you look it all up on PhotoMath or if you type it into your favorite AI and have it do all your homework for you. I'll never know. Okay, and you can do that. You're robbing yourself because you're supposed to learn how to do this stuff, and it will come up in other classes. For the biology students, I have it on good authority that this comes up in ecology. So if ecology is going to be in your future, this is a thing you want to be able to do because when you get to that class, they're not going to have time to go back over and do all of this stuff for you. So you should learn it now because later classes that may come back to use this, they won't have time to teach you. The other thing I would tell you to do it honestly for yourself is that I've taught this class a few times, and it is absolutely heartbreaking for both me and you, more you, but when I see a test and pages 1 through 5 are just simply written, I don't know. And that's the only thing written on the all eight pages of my test. or I don't remember. I'm like, I'm not a priest. I can't offer you absolution. I can't forgive you for this. Okay. So unfortunately, when you break this down, I have no option but to flunk you. And I want to see you be successful. I don't like flunking students. I like seeing you guys do well and pass and move on from this to what the next stage of your life is. I want to see you do that. I don't want to see you have to take the class again and again and again. Okay. I want to see you like, hey, let's get it done once, get done with it, and then move on. So please try to do the homework honestly. I mean, I get there's going to be certain problems where you're like, I don't know. And I'll warn you, okay, there are certain problems. Like I'll warn you, like this is a test problem. So you're going to definitely want to get tutoring for problems that you don't know how to do. And I'll absolutely help you. But try to make sure you can do the problems yourself rather than completely relying on the thing. So Sherman over, and I will see you in the next video. So thank you very much for watching this one, and we'll talk a little bit more about derivative rules in the next video. Thank you, and I'll see you next time.